Hello again. I'm going to try and do a little work with electron configurations in the periodic table. So I've got this groovy periodic table and it does all kind of whiz-bang stuff, and so I'm going to try and use it. Part of the reason I'm going to try and use this periodic table is because I can't write. I can't write on the screen right here, so I can't write electron configurations as I'm doing them. But I can make this thing, excuse me, I can make this thing pull up periodic or electron configurations. So I'm going to click a tab you can't see, and it shifts the periodic table a little bit, and it took helium from right there and put it right over here, and there's a reason for that. At least in context for what we're doing right now, helium should be right there. In context of the way the periodic table is organized and the reason the periodic table is organized the way it is, helium should be right there. But at the moment we're talking about electron configurations, and helium is nice and handy right here. So with the information that we had from yesterday, I guess, yeah, we can call it yesterday, we were working on that patterns in electron configuration, and these elements right here, the last electron went into an s orbital. Oh, in fact, it's kind of handy. Watch, as I move the mouse, it goes to helium, and right over there it shows the electron configuration. So this may work okay. So hydrogen, again from yesterday, the period number right there and the energy level number are the same number. And then subsequently the last electron that went into these elements went into an s orbital. So look at that. Over there, lithium is 2s1, so the last electron went into second energy level s orbital. Oops, it's right there. Lithium I mean. And there's that last electron went into an s orbital. And there's magnesium, and the last electron went into the 3s orbital, and there's 2 electrons in that 3s orbital. So for that reason, these elements are all called the S block. S as in Sam, the S block. Similarly, all of these elements over here are called the P block. All the way, every group from boron all the way through the noble gases are the P block. And see right there, boron, the last electron goes into a p orbital, it's p1. And gallium, the last electron that goes into the element, is in a p orbital, p1. And chlorine, the last electron goes into a p orbital. Okay, so this is the P block. The green ones, all these green ones, including those two right there, are the D block. If I hit this, another thing you can't see, it makes the periodic table spread way out, and I don't know if I can make that, I can shrink the size of the periodic table. If I can't, I'm in big trouble. I don't know how to. Well, I can do that. So it scoots over. I wish I could unzoom the screen. I don't know how right offhand. I mean, I do know how, I'm just not seeing it. So that, all those elements right there are the D block. Quit it. And then with the wide thing, the elements that are usually in the inset, this thing right here, this inset right here, those elements are now where they actually should be. Those elements should be right there. And all these guys are the F block. So the S block, the F block, the D block, and the P block. Alrighty then, so I'm going to undo that wide thing so we can see what we've got going on. So the idea now is to be able to read an electron configuration off the periodic table. And to do that, you link the period number or the energy level number and the blocks together. And other than that, what one needs to know is that each box is one element, or one electron. Yeah, it's an element, that too. But it's one electron. So, for example, hydrogen has one electron in it, and you just click over one, and helium has 2 electrons in it. So each box is a placeholder for an electron. And you click down to lithium. Lithium has 3 electrons in it. 1, 2, 3. Beryllium has 4 electrons in it. 1, 2, 3, 4. There you go. Each box is a placeholder for an electron in this context. So, to read an electron configuration off the periodic table, you need to know there you go, we'll go to hydrogen. Hydrogen's electron configuration is 1s1. Hydrogen only has 1 electron. And that 1 electron goes into the lowest energy orbital, and the lowest energy orbital is energy level 1, s orbital. So it is in the electron configuration is 1s1. There's the orbital diagram right there, 1s1 with an electron in it. So then you go to helium. Helium's electron configuration is 1s2, and there is the orbital diagram with 2 electrons in the s orbital. So to do that by reading the electron configuration off the periodic table, you read the energy level or the period number, the block, and then just count the number of electrons over. So let's do oxygen. So I'll do oxygen, and then I'll click on it, and the electron configuration will appear right there. So oxygen is in the second period, or energy level 2, and for there to be electrons in energy level 2, energy level 1 has to be completely full. So the 1s orbital is completely full, so I'll just say 1s2, and then we click down into the second energy level, and then start across the s block right here. So that would be 2s1, 2, and then keep going across the periodic table, and we'll click into the P block. So this would then be 2p1, 2, 3, 4. So the electron configuration of oxygen should be 1s2, 2s2, 2p4. Bada boom, bada bing. And there it is, 1s2, 2s2, 2p4. And there's the orbital diagram right there with the electrons in the 1s orbital and the 2s orbital. And then they went in there one at a time. Click, click, click. And then this one paired up by Hund's rule. In fact, watch, I'll go click nitrogen, and the electrons will all be in there the same, with the same spin state and the whole deal, just like we did in class. This is a trick periodic table. Okay, so that was oxygen. Let's do magnesium. So I'll do magnesium right there, and I'll do the same thing. And magnesium is in the third period, or the third energy level. So energy level 2 and energy level 3 are completely full. So to get to magnesium, I have to fill all this up, all that up, and then get down to the third energy level. So magnesium, 1s, 1, 2, 2s, 1, 2, 2p, 1, 2, 3, 4, 5, 6. Into the third energy level, 3s, 1, 2. So the electron configuration for magnesium should be 1s2, 2s2, 2p6, 3s2. Bonk. 1s2, 2s2, 2p6, 3s2. Bada boom, bada bing. Hallelujah. And there's the orbital diagram for the whole deal right there. So then let's do iron, because iron has the weird deal where the 3d orbitals lag, the energy level of the d orbitals lag one behind the period number. Okay, so iron right there, it's in energy level 4 or period number 4. So everything above it is all full. So 1s, 1, s1, 2, 2s, 1, 2, p, 2p, 1, 2, 3, 4, 5, 6, 3s, 1, 2, cruise across, 3p, 1, 2, 3, 4, 5, 6. Click into the fourth energy level, 4s, 1, 2. You get into the d orbitals, they lag one behind, so that would be 3d, 1, 2, 3, 4, 5, 6. So the electron configuration for iron should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, I think I said 1, 2, 3, 4, 5, 3d6. Bunk, and there it is. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. And there's the orbital diagram, the whole thing. And this weird looking deal over here, that picture right there is what the d orbital that electron is in looks like. And that is the d, or that's a picture right there. Sugar. Right there is a picture of the d orbital that electron is in. If I go over here, it will, and click on these, it will just show a p orbital. And if I go over here, it will just show an s orbital. That shows the concentric s orbitals. The one in the, man, no, it doesn't work. So there's the s orbitals right there. There's s orbital right there. That's pretty neat. So we probably should do one with an f orbital, and this will take a minute, and I don't know if I can remember because I can't write the electron configuration down as I go, so this will be a wreck. But we'll give it a go. Let's do cerium. So cerium is in the 6th energy level. So you cruise across, you hit cerium, and you go barium, cesium, barium. Oop, I'm in the F block, lanthanum, cerium. So you go into the F block, just go skip. I would do it wide, like that. Then you go cerium, barium, lanthanum, cesium, barium, lanthanum, cerium, like that. But I can't count the D block, so I'm going to unwide it. And it's like, okay, cerium, here we go. So it's in the 6th energy level, so everything above it is full. So I'm just going to fill them up. 1s, 1, 2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4 back into the 4th energy level with the p orbitals, 4p6, 5s2, 4d10, 5p6, 6s2, click into the F, but remember the F lagged 2 behind. The energy level of the F orbitals lagged 2 behind the period number, so that was 6s2, 4f1, 2. Although these F orbitals sometimes screw things up. They do. That one did. I'm going to go to that one. That didn't screw it up. It would take a while to explain what happened right there. There's a reason for that. But let's do this one. And so the whole deal is all there. 1s2, 2s2, 2p6, the whole thing all the way down there till you get to 6s, 1, 2. Then you click into the F orbitals, F1, 2, 3. So that's 4f3 right there. And there you go. Reading electron configuration off the periodic table. And yes, that one didn't exactly work, and there's a few that don't work the way you're supposed to, at least in accordance to strict adherence to the rules. There's one right there. Chromium won't do it either. It will be 4s1 3d5. See that? 4s1 3d5. So it put one electron in the s orbitals and then bumped the electron that should be in there up into the d orbitals. And there's a reason for that and the whole enchilada, but don't worry about it. If that were a test question and you put chromium 1s2, 2s2, 2p6, 3s2, 4p6, 4s12, 3d 1, 2, 3, 4, I would mark it correct. Alrighty then, take care then. Bye now.